Okay, this is a video that will cover different types of energies for atoms and how they relate with each other. All right, let's get started. Electronegativity. This is something we've already covered in class. The ability of an atom to attract electrons from another atom that it is bonded with. Now, a simple example of that would be hydrogen, when hydrogen bonds to itself. That's a very, very simple thing for us to look at today. Okay, and we'll put two dots and show that hydrogen's bonded like this. Okay, so why are two atoms attracted to each other? So we have a positive charge in the nucleus of the atom, and then we have another positive charge of the nucleus of an atom, and there's an electron buzzing around each atom somehow. Okay, so why would there be attraction? Well, let's look at this nucleus here. The nucleus is positive. It's going to be attracted to the negative of this electron here from this hydrogen atom here. And likewise, this electron here will be attracted to the nucleus of this atom here. So when atoms bond with each other, there's always like a pull. It's like a tug of war between the two atoms for those electrons. Why? Because the nucleus of one atom is always attracted to the electrons of the other atom. This, of course, represents H2, which is a molecule that has equal tug for electrons. This, of course, would be a completely nonpolar molecule. We use electronegativity to define the bond character, okay, for bonds between atoms, this in case being completely nonpolar. But you can get unequal sharing of electrons causing polarity in molecules to actually happen. We, of course, need to check symmetry for that. Okay, the next one. Ionization energy. Ionization energy is the energy required to remove the outer electrons, okay, from atoms. Okay, if you have high ionization energy, that means you really want to attract electrons towards yourself, and you're not that willing to get rid of electrons. Therefore, it's going to cost a lot of energy. Low electron ionization energy means, you know, whatever, just take my electron, I really don't care for it. It's not going to take much energy to remove it. Why is there energy required to remove electrons from an atom? Well, again, let's take a look at the nucleus of this atom. There are some neutrons of no charge, and there are positive charges here inside the nucleus. The positive charges are going to attract the electrons of that axial atom. So because they're opposite charges. So it's going to take energy to pluck that electron off of the atom. Now, if we draw an atom of sodium, for instance, with one dot, sodium does want to give its electron away to chlorine. Chlorine has, of course, 7 dots. Okay, and we see that the sodium atom will give up its electron and give it over to chlorine, making this a negative charge, and of course this will be a positive charge. But because the nucleus of the atom of sodium is a positive charge, that electron will be attracted towards the nucleus of that atom. And it indeed is going to take energy for chlorine to pull that electron over. The energy it takes to take an electron from the nucleus of an atom is known as the ionization energy. You know, imagine here you got the planet Earth, okay, and then you've got some kind of a spaceship. I'll make this real simple. Gravity of Earth is pulling that spaceship around the Earth. If you want this spaceship to escape the planet's gravity, you're going to have to put energy into that and make it to go away. So that's just kind of an analogy to help you understand. Very similar to this right here. These electrons that are buzzing around, orbiting around somehow, remember they're in S shapes and P shapes, they are indeed attracted to the nucleus of atom by opposite charges, and it would take energy in order to get rid of those electrons. Next thing, electron affinity. The energy released when an electron is added to an atom. So if it takes energy to get rid of an electron, there's energy that gets released when an electron is added. It's the opposite process. Well, let's take a look at this one here. This is sodium to chlorine, what I just said. So Na positive is like this. So again, sodium, of course, has 1 dot. And let's take a look at chlorine again. So why would chlorine release energy when an electron is added? And the answer comes from the idea that right now, this is not stable. So when sodium gives its electron over and places it here, we of course make a -1 charge. This makes a +1 charge. Why does energy get released? Well, it gets released because now you've made something very stable here. There's 8 dots around chlorine. and that becomes very, very, very stable. So energy is released when an electron is added to an atom. Now, if it's not released, that means an electron, let's say sodium wants to receive an electron. Well, then that's going to make it more unstable. Therefore, sodium might have, it may not want to take on an extra electron. So I want to point out to you all that not every single atom may want to get an electron. Okay, but definitely our nonmetals, when they receive electrons and become stable, there will be energy released, okay, when that happens. Next, atomic radius, the distance from the nucleus of an atom to the outermost electron. So remember, we're looking at a cloud model. This is the center of the nucleus. So imagine me drawing like a distance from here all the way out. This is going to be the radius. Okay, now the electron cloud really isn't this nice and perfect. Remember, it does scatter out a little bit. So the atomic radius value is going to be an average value from the nucleus out to the outermost electrons. So it's going to be an average value. It's really what size is our actual atom. Okay, the bigger the atom, of course, the larger the atomic radius. Okay, and those are some of our properties we're going to be looking at on the periodic table, which are called periodic table trends.